So we have previously been looking at solving quadratic equations, and we use different algebraic methods like factoring and the quadratic formula to do this. Starting in this next unit, we're going to be transitioning into what that looks like in terms of graphs of quadratic equations and some information that we can gather when we see the picture of a graph. So here we have the standard form of a quadratic again, ax squared plus bx plus c, where a obviously does not equal 0. And using our a, b, and c values, we're going to be able to find out some information about the quadratic function that we're given. So here's a look at what the graph of a quadratic equation looks like. The graph is called a parabola, and the roots, zeros, x-intercepts, or solutions are where the graph intersects the x-axis, or the value of x whenever y is equal to 0. All of those names are interchangeable, so you will see them multiple times written in different ways. The axis of symmetry of a graph is the line that divides the graph in half. So in this case, it's actually going to be our y-axis since it's centered around that line. And the vertex is the minimum or maximum coordinate point on the graph, so the lowest or the highest point that it reaches before it turns around and changes direction again. So once again, the graph is a parabola. Looking at our a value, if a is greater than 0, the parabola is going to open up, just like the example that we just saw. If a is less than 0, the parabola is going to open down. The axis of symmetry is found by taking your b and your a values and setting them into the following equation, negative b over 2a. That also is going to give you the x-coordinate of your vertex. Once you have that, you can just plug in the x-coordinate back into the equation, and by substituting that, you'll get your y value. Then if you're asked for the y-intercept, it's always where x is equal to 0, so it's going to be whatever that constant term is when x equals 0, or if you're looking at the graph, where you can see it cross on the y-axis. We talked about this briefly before, but there are 3 different possible solutions to quadratic equations. You either have no solution, where it does not cross the x-axis at all, one solution where it touches or sits on the x-axis, and then 2 solutions where there's 2 distinct places that it's going to cross. So looking at this first example here, we're using negative 3x squared minus 6x plus 8. Knowing that our a value is a negative 3, we automatically know that our parabola is going to open down. To find our vertex, we use x equals negative b over 2a. Okay, so we have a positive 6 over 2 times negative 3, which is going to give us a negative 1. That's your x-coordinate. We're going to substitute that back into the equation, and when we do, our y value is 11. So negative 1, 11 is going to be your vertex. The axis of symmetry, remember, is that same line. So negative b over 2a gave us negative 1. That means our axis of symmetry is x equals negative 1. This is always written as an equation, so always x equals. Then the roots and solutions are obviously where those cross the x-axis. In this case, it's going to have 2, and we'll talk about here in a minute how we actually calculate those, but for now, we're just going to leave it at there's 2 solutions. Then to find your y-intercept, you just plug in where x is equal to 0, and when x is equal to 0, y is equal to 8. So your y-intercept occurs at 0, 8. So let's plug in a few coordinates. You want to put your axis of symmetry in the middle, because that's going to be the middle of your graph. So graph a few coordinates on either side. If we go from negative 1, 0, and 1, and then we can go 2 to the other side as well, so negative 2, negative 3. We're just going to plug in each of these values in for x in the equation. So if we plug in negative 3, our y value is -1. Plug in -2, and we get 8. -1, and it was 11. That was our vertex. 0 and 8. That was our y-intercept. And then 1 and -1. You should notice that this forms a pattern around the axis of symmetry that's going to create that parabola shape. So if we go ahead and graph what we have here, starting with the vertex, 11 is going to be just a little off your graph up top. Then we go -2 and up 8, and -3, down 1. Over here, we have 0 and up 8, and then 1 and down 1. So here is our parabola. So this one is going to have a maximum value because we have a highest point that it reaches before it turns back the other direction. That maximum value is where your y value of your vertex occurs. So the value at your maximum is 11. Let's look at one more example here. You have x squared minus 4x plus 1. Since our a value is positive, a is equal to 1, then it's going to open up. We're going to find our axis of symmetry by doing -b over 2a. So our axis of symmetry is going to be x is equal to 2. That's your x-coordinate of your vertex. So your x-coordinate would be 2. And then we're going to substitute that back in, which gives us a -3 for the y value. I'm going to go ahead and come over here to my graph and put that in the middle. So 2, -3. Graphing a couple of points on either side, we would have 0, 1, and then 3 and 4 here. So when we evaluate for this 0 value in the table, that's going to give us our y-intercept. Plugging in 0 for x means that y is equal to 1. So over here, we have a y-intercept at 0, 1. And if we go ahead and evaluate these other couple of points, plugging in 1 gives us a value of -2 for y. Then we have -3, 3, -2. And then when we plug in 4, that's going to give us 1. So let's go ahead and graph what that looks like. 0 and up 1. 1, -2, 3, -2, sorry, 2, -3, and then 3, -2, and then we have 4 and 1. Sorry guys. Okay, so here's our graph. This one is going to have two solutions because it once again is going to cross the x-axis twice. It's going to have a minimum value since it opens up and has a lowest point, and that value, remember, is the y-coordinate of your vertex, so it's at -3. This next example, you have y equals -x squared minus 2x plus 3. Since our a value is equal to -1, that means it's going to open down. Looking at our axis of symmetry, -b over 2a, x is going to be equal to -1. That is our x-coordinate of our vertex. So we plug that in for x, and that gives us a y value of 4. So I'm going to come over here and put that in the middle of my table again, -1, 4, graphing a couple of points on either side. And these are the y values that you should get around each of those. So at x equals -3, y is 0. At x equals -2, y is 3, negative 1, it was 4, and then it goes the other direction. So 0 is at 3, and 1, 0. Once again, this one is going to have two solutions when we graph those. And notice that your y-intercept is given to you over here in the table. When x is equal to 0, y is equal to 3. So let's go ahead and graph. We have negative 3 and 0. Then we have negative 2, up 3. Negative 1, up 4. 0, up 3. And 1. Whoops, sorry, that should be 0. So here is our parabola. Notice the difference with this equation. You can actually see where your solutions occur. You can see where they cross on the x-axis. So we're actually going to go ahead and write what those two solutions would be. Here we have an x value of negative 1, 2, 3. And then over here we have an x value at positive 1. So our two solutions are at x equals negative 3 and x equals positive 1. If you look back at the equation, with the exception of this having a negative a value, and we would get rid of that if we wanted to graph it, or I'm sorry, if we wanted to factor it, then these would be the solutions if you were to factor this equation and set it equal to 0. So it's just showing you on the graph what we've been solving for previously. Since this one opens down, it has a maximum value, and that value again is going to occur at the y value of your vertex. So its max is 4. What I would like for you all to do right now is go ahead and work example 4 on your own, and then we'll go back and check that one before you have some time to practice. Alright guys, so hopefully you've had a chance to look at this last example. Notice that your a value is equal to 1, and so it opens up. Your axis of symmetry, when we do negative b over 2a, is going to be equal to 1/2. Again, we write that as an equation, so x equals 1/2. Your vertex x-coordinate is 1/2. Plugging that back in gives you a coordinate of negative 6.25. You will notice that in my table, I did not actually write the vertex as one of my coordinates. Since it didn't fall on an integer value, it's a little bit easier to graph just the ones around it. But looking at the graph, you can see over here that I actually graphed it as the vertex there. So it has two solutions this time. Those occur at negative 2 and at 3. Your y-intercept, when x is equal to 0, is a negative 6. And it has a minimum value at the y value of your vertex, so negative 6.25.